So the week 7 folder is now available to you guys on Brightspace. It looks something like this, of course. So there's a bunch of stuff in here. Most of it's related to assignment 4. We're going to get into that a bit down the line today. But starting with the task list itself, I have a copy of the week 7 task list here. Same usual suspects for our resources. Where we get kind of the more important details here is task 1, task 2 for this week. Task 1, we're going through chapter 11. So we're skipping ahead a couple chapters. Again, we're going to talk about trim, extend, and offset. Chapter 11 is all about some of our more advanced editing commands. We've already kind of worked with trim and offset to some extent. So it's just going to be a little bit of a review. We're going to go into a little bit more detail about some of the options we can get out of those commands. We'll also talk about a couple other kind of subcommands in this category, which are going to be break and break at point as well. So it's going to be kind of light on lecturing this week. We don't have too much in terms of lecture. There is practice 11A, 11B, and 11G for this week. These are going to be related to trim, extend, and offset again. You've used trim and offset a bit in assignment 3, but this is just to kind of get you a bit up to speed with some more of the advanced options that you can get out of those tools, and just some more practice because we've taken a break for a bit. Maybe you need a bit of a brush up. This is just kind of to help you with those commands. On top of that content, it's a bit light for this week, but what also comes out this week is assignment 4. So that is the Arena AutoCAD Lighting Layout assignment. This is also all located in the week 7 Brightspace folder. So we're going to go through that today as well. I'll give the instructions. There's going to be some time towards the end here because I don't have that much to lecture about for you guys to get started on it if you choose to get started on it, or just kind of wrap your head around the assignment itself. There's a lot of files that go along with assignment 4. If I go back to the week 7 folder here, all 5 of these files here, apart from the task list, are related to assignment 4. That sounds kind of daunting. It's not a huge assignment or anything like that. There's just a lot of details that kind of go into it. So there's a lot of different PDFs that you're going to be drawing information from. Okay. Any questions about what to expect for this week at all? So far, so good. Okay. So if there aren't any questions, we'll get started. So just like the task list says, we're going to get started with just some of our advanced editing commands in chapter 11, starting off with trim and extend. We've talked about trim in the past. Of course, just as a bit of a refresher, if I draw any objects where kind of lines intersect, maybe something that kind of looks like this, just a little collage of different objects here. If I use my trim tool, which is the little scissors icon on my modify panel, I can also type in trim as the command itself. This, of course, allows me to remove objects based on cutting edges or where intersections are of that line segment. So if I hover over any of these line segments, you can kind of see it grays out, and it's detecting an intersection along the circle here for this line, as well as along the square or rectangle there, and it's removing the line between those 2 points, between those 2 intersections. Okay. I can also click and drag, and that allows me to cut multiple things or trim multiple things at a time. And we're mostly kind of familiar with this. A couple things about trim that we're going to tack on to what we know about it so far is that it also has the little down arrow on the dynamic input prompt, meaning that there's more options here. And our options here starting with cutting edges, we can define to AutoCAD what those boundary edges should be that the trim tool is going to cut between. So if we don't necessarily want AutoCAD to automatically check for the very first intersection, we can go into the tool itself and kind of define where it should be looking for intersections. So if I choose cutting edges out of this list, it's going to ask me to select objects to act as those cutting edges. If I select something like the square here and press enter, I've now made the square my boundary. And if I go to trim this line segment now, it's using the square as the boundary to look for intersection points. So without that setting, if I go to trim this line segment, it's looking for the first immediate intersection between the line and the circle, which would be right up here and down in the bottom left here. And you can see as it grays out, it's checking for those intersections. But if I go into cutting edges and define the square as the boundary instead, then when I go to trim, it's instead looking for the first intersection of the square rather than the first intersection it sees, which would be in the circle. Okay, so you can kind of prompt AutoCAD to look for a specific object that it's going to be looking for intersections in, rather than the very first intersection available. Okay, so then I can go ahead and click on this line segment, and it's going to trim everything, that entire line segment that's contained within that boundary edge, the rectangle that I selected. Okay. With trim as well, I can switch its mode in this down arrow menu again. The mode here is set by default to quick. I can switch this to standard, and instead of just clicking on things and they just immediately trim, setting it to standard, sometimes if it's going to allow me here. Yeah, I'm on standard. Allows me to select objects and then press enter and then go along and kind of trim based on objects I select. It's using those boundaries again. Okay, so it's like kind of going into a bit more, it allows for more steps for the trim command. With the quick, again, it's just going to look for the first intersection and then just go ahead and trim. With the standard mode, then I can kind of go and select objects and then trim within those objects. Okay. And finally, with trim, we also have I start with trim here. We go back to quick. We also have crossing in this list. With crossing, it's going to allow me to make a crossing selection, and anything that crosses the crossing selection will be trimmed. So again, if you want to kind of trim multiple things at once, this is an option that's available if you want to trim kind of multiple lines all in one go. Okay, so you can see any line that crosses the crossing window is going to be trimmed. Anything that's within that crossing window or outside of and doesn't touch that crossing window is going to be left perfectly intact. Okay, so if I bring it across here, it intersects with those the north and the east kind of quarters of that circle, and the diagonal line in the middle there, and the kind of north and east sides of the square or rectangle. So it's going to trim those. Okay, whereas this hanging segment up here and this little last edge of the east side of that rectangle are left intact because they're still within the trimming window. Okay. In the standard mode, there's also a fence option for the down arrow menu. And with fence, this just allows you to kind of click around and draw line segments. And across these line segments will also be trim. Okay. So again, if you choose to use this method to kind of cut multiple lines at once, of course, you could always instead just use the quick trim, switching it back to quick, and then just clicking and dragging, effectively the same thing. If you prefer using the crossing window or using the fence option, those are available to you. Again, with most, just like with most AutoCAD tools, whatever kind of works best for you is whatever to kind of go with. Okay. So that's a bit of a kind of re-review of trim. I've kind of used it in the past, but there's a few extra options you can kind of play with in that down arrow menu there. With trim is a newer command that we haven't really talked about yet, which is extend. So with the trim tool on my modify panel, there's a little down arrow beside it, again, meaning more options. If I select that down arrow beside the trim button, I also get the option to extend objects. So what extend is going to do is that if there's any line segment or any object that doesn't quite reach a boundary edge, or basically another object, it's going to extend that line segment or that object until it does reach the first kind of object that it comes in contact with. So what that kind of looks like here is that if I draw a rectangle here and a line through it, if I want to extend this line segment so it goes across the entirety of this rectangle, then I can use extend. And then as I hover over that line segment, you can see it's being extended to the first boundary edge that it sees. So very similar to trim, where it's looking for an intersection point or the first boundary, and it's going to extend or lengthen that line until the first boundary it sees. Okay. So again, extend in the modify panel. I've just selected it. Hovering over this line gives me a preview of the extension. And then by clicking on the line, now that line is extended all the way until it reaches that side of the rectangle. Okay. And these two lines will join perfectly. There's no space between there. So this is a method of kind of joining, or well, making lines touch precisely. Okay. If I were to then use extend on the line on the right, so I extended the left part of the line to reach the edge of the rectangle. If I try to use extend on the right side here, that's hanging out of the rectangle, it's simply not going to let me. If I try to click, I get an error message in my command line here, or my command history, and it says path does not intersect with the bounding edge. So if there's no boundary edge or no object for this to be lengthened to, you simply can't use extend. There has to be some sort of object in the way here that it's going to extend to. Okay. Because of course, if there's no boundary edge that's defined, it can't just make an infinitely long line all the way down your drawing area. Okay. Same if I put a line here as kind of the boundary, I can use extend so it extends all the way to that line segment. Okay. With extend as well, we have similarly the down arrow menu here. In here, again, we have boundary edges. So if we don't want extend just extending to the very first object that it sees, but maybe an object that's kind of further down the line, then we can set what the boundary edge is supposed to be. So if I have this rectangle here, and I'm just going to divide it into two rectangles, and again, I'm going to draw my line here that kind of crosses the larger rectangle here. If I go to extend this line, it's going to look for the very first object in the way and extend to that object. So in that case, this would be the halfway point of the two rectangles. If I go down to boundary edges and redefine where the boundary is, so I can select boundary edges here, select the object that's going to be the boundary, press enter. Now I can extend past that dividing vertical line and all the way to the edge of the larger rectangle I initially drew. Okay. So this might be kind of useful in things like when you're doing your title block. If I go back to, I think I have it in my recents here. So if I were to kind of draw this title block and I was kind of dividing it up here, and I made these boxes and I just want to split this in half, maybe I use the midpoint here on this title block and I kind of drag it across. I might not immediately have a snap available here. Because if I use the midpoint here, this isn't a midpoint because the line extends all the way to the top of the symbol legend in this case. I might draw the line, just have it horizontal, and then go in and extend it all the way over to that far left edge. Okay. You can also do this with multiple lines at once. If I trim this out here, I can extend multiple lines at once. Maybe I'm drawing something like a piston or something like that, and I want to extend to the actual cylinder of the piston. Then that could be an option. I can extend multiple lines at once. There's a bunch of different applications for this. It doesn't seem immediately kind of terribly useful, but there are cases where you might want to use it out of convenience. Okay. Oops. Actually, I can just leave this drawing here. Any questions about trim or extend so far? Okay. Moving on then. So with trim and extend, we also kind of have two kind of associated commands or tools. These are break and break at point. So what break and break at point are generally for kind of breaking up line segments, either by creating a gap. In the case of break, we'll choose 2 points along a line and break between them to kind of make a gap. Or with break at point, we can select a specific point along an object or a line to divide it into two separate objects. So if I have a line like this, I'm just drawing casual horizontal line here. In my modify panel, break and break at point are actually in this little drop down extended menu. So I have to select the modify button here and I get a little extended menu just by clicking on the word modify itself. And break at point are these two rectangles here with kind of the blue lines perpendicular to them there. Okay. So we have break and we have break at point. So starting with break, if I choose break here, it's going to ask me to select an object and then select a second point. When you go to select your object with break, it's going to immediately choose wherever you select on that object as the first point to break from. So if I select kind of around here on my line segment, it's going to immediately break as soon as I select that object, and it wants me to specify a second point to break to. So I'll choose that kind of in the last quarter of the line here. If I select this point here, then I've broken this line segment into two separate line objects. and now there is a gap between the two. Okay. With break as well, after you've selected the first point, since it's kind of clumsy here where it asks to select an object, but it's actually selecting for the first point as well. If you select anywhere on this line for the first point, you can also go back to the down arrow and re-choose the first point. So I can go down arrow, back to first point, and it'll give me my proper crosshair so I can kind of use object snaps again. Okay. So I can choose the midpoint here, and then it goes back to selecting the second point. I can insert some sort of number here if I'm using object snap tracking, like a value of 2. Press enter, and now I have 2 line segments, and the distance between them is exactly 2. Okay. So where this kind of comes in handy pretty often is when we have crossing lines. It's a very common use case. Often with diagrams, you have a bunch of lines pointing to different objects and things like that, and they kind of crisscross and it gets really confusing visually. So what happens often is that if we have 2 crossing lines, something like this, and maybe they're pointing in 2 different directions here, I might use break to break up this line here. And now there's a bit more of a visual clarity of which line kind of belongs to which here. There's no weird direction changes going on. I know that this line is supposed to pass through the horizontal line. And to kind of show that in practice, this is a process flow diagram. I think I've brought it up before a couple weeks back. But in this case, of course, this being process, it's more chemical based, but besides the fact it's still applicable. We have hydrogen passing through this line here. And we don't want this to be confused with whatever's flowing through this other line coming off the top of this vessel here. So they've gone ahead and broken this line to kind of aid with visual clarity there. Okay. Just to kind of show that those 2 lines aren't part of the same kind of continuous line segment. That break kind of shows that there's no weird kind of crossing going on there, or like a T or anything like that. These are distinctly separate lines. Okay. So what would have happened here was that this was originally a full line that they drew. I'll join it just so it's 1 line segment. So I had 2 crossing lines just to prove that this doesn't actually go in all 4 directions. These are 2 separate linear pipelines. They've gone ahead and just taken break and then braked on both sides of this line here. And I think it accidentally grabbed a object snap there. So they just broke it across. Now I know the horizontal line and this vertical line do not interact. Okay. Same thing goes with wiring diagrams. You might have wire that kind of crosses each other. To show that that isn't a 4-directional connection, we'll break that line to kind of distinguish that the horizontal line is not joined with the vertical line. Okay. It also comes into play quite a bit with dimensions. We haven't talked about dimensions just yet, of course, but often when we have dimensions kind of crossing each other, if I draw something like a rectangle here, and I dimension this out, so I'm just putting dimensions in this rectangle here. So since these dimension lines kind of cross each other, it gets a little bit confusing to people that just look at this. So we might put in a break into this dimension, and it puts this little space in here for us, just so it's a bit more visually distinct that this arrow belongs to this value and not kind of associated with any other number here. Okay. So it's just more visual clarity again, just to kind of help out with that. In some cases, you might also use break just to create that gap. Maybe you do want to make that gap for some specific purpose. Maybe you drew out the walls in a floor plan and you want to break an area so you can fit in a door or fit in a window or something like that. That could be a use case. So it does come in handy pretty often. Okay. We also have break at point. So along with break is its cousin here, break at point. So with break at point, it's again going to break this single object, this single line segment. It's going to break it into two separate objects. But in the case of break at point, it's not going to create a gap. So I can use modify, go to break at point, choose this object, select a point along the object to break. I'll use the midpoint. And now I have two equal length line segments. Okay. So this can be useful in some ways. Sometimes we want to kind of change maybe what this line length is. Maybe this was supposed to be an arc, and we want to remove this and put an arc in its place. Or again, if we're kind of arraying a grid out, we talked about potentially putting points along the line to kind of divide it up into equal segments. You could also use break for this purpose. So if I were trying to take a line segment and turn it into 7 divisions of that line segment, I could go ahead and try to put points along here or use the divide command to put points along that line. Or I can just use break and break every 2 units, let's say. To kind of break it up into these separate line segments. And then now, since I've broken it up, I now have endpoint snaps in order to kind of divide this out, rather than the node snaps that points provide. So there is a bit of a catch to this as well. Since I've broken these line segments up, when I go to divide it, these are now no longer one object, so I can't use something like erase to erase this entire line segment at once. So there's a bit of a catch that you are breaking it up into separate objects, and therefore you can't really use object basis tools on it anymore, things like erase. So that's something to kind of keep in mind. But in some cases, people prefer kind of the visual clarity that using break uses over something like node. They might not like the circles with the crosses all over their drawing. So it is another method to kind of do something like that. Okay. Any questions about break or break at point? Okay. Finally, a bit of a re-review into offset. So we've used offset already, making our offset kind of guidelines in assignment 3. With offset, just as a bit of a refresher, this is going to create a line by a defined distance away from our original line. So if I have something like a line segment and I use offset, this button on my modify panel here, it's also the shortcut O. I can specify any distance. I'll put in 10 units, and this is going to create a duplicate of that object, whatever distance away that I've defined, away from the original. So I put in 10 units. It's now making a line offset 10 units away. Whichever side my cursor is on is the side that that offset will be placed. And I get a bit of a preview as I hover my cursor around. And all I have to do is just click and it creates that offset. So we've kind of used that in assignment 3, going into a bit more detail with offset. If I choose, I'm going to make a rectangle and then explode it. If I choose in the down arrow menu, the through option, the through option is going to allow me to kind of freehand click where this offset's going to be placed. So in our practice so far, we've entered the exact offset distance. Maybe we don't really know what that exact distance is supposed to be, but there's maybe an object snap that we're supposed to be using as the kind of location for that offset. So I can choose through in this case. I'll choose the right side of this rectangle. And then with through, I can now, just by moving my cursor around, place this offset wherever I want it to be. So before we entered the specific distance that that offset might be placed, maybe this square is already on a pre-existing drawing, this rectangle rather, and I just want to find the midpoint. I could go up to the midpoint snap here and then place the offset. Okay. So through is going to allow me, it's kind of like with other tools, you can either type in the exact value that you want it to be, or you can kind of rely on object snaps and more using your mouse and clicking to determine where that offset should be. Okay. With offset as well, we also have a couple other options in our little down arrow menu here. We have erase and layer. Erase is going to determine whether the original object that you are offsetting from is going to be erased or not. So if I choose this and switch it to yes, by default it's set to no, so the existing object stays. If I switch this to yes and try to offset this, offset this line here, then you can see it grays out after I've selected it. And as I choose, I'll pick the midpoint again here on the rectangle. When I choose this point as the offset, then the original is erased and I'm only left with the offset line itself. Okay. So maybe if you need to move a line over and you don't really care about the existing one because you're just trying to move it over a certain distance or what have you, that can be an application as well. Finally, with offset, we also have layer. So with layer, we talked about layers just before the break. This is going to determine whether the offset line that I'm creating is placed on the current layer or if it's going to match the source object's layer. So if I'm going into my layer properties here, and we're going to make a couple layers. We'll make this one kind of magenta, I guess. So if I go to offset, by default, the layer is set to source. So whatever I offset is going to match the layer of the source object. So I can choose through in this case, choose this line, place it back where it was, and it's also going to be on layer 0 because the source was layer 0. The offset is also going to be layer 0 because it's matching the source. If I go back, I'm going to turn eraser back to no. If I change my layer now to my layer 1, which is in red in this case, and I type in my offset and change the layer to current, then my offset is going to be set to the current layer rather than matching the source layer. Okay. So now when I create my offset, it's on my current layer, the layer displayed in my layer control here, which is layer 1. I can then switch it to something like layer 2. Again, if I go through these options, the new layer is set to the current layer. Okay. This is going to come in handy, especially with assignment 4. We're going to be drawing guidelines in assignment 4. And of course, the new assignment is going to cover stuff that we've covered just prior to it, that being layers and some of these advanced editing commands. So this is going to come pretty handy for assignment 4. Okay. If I set my offset to source, then again, it's going to match whatever the source object's layer is. Okay. So in the case of assignment 4, we're going to have a floor plan of an arena. Most of those lines are just structural lines of the walls. We're going to make guidelines that we want specifically on a guideline or grid layer. So it'll be helpful if you take the structural lines that are on the structure layer, switch your current layer to the grid layer, and then use offsets and set that option to the current layer so they can be placed on the correct layer rather than the structural one. You want them placed on the grid layer instead. We'll kind of show what that looks like as well when we get into assignment 4 today. Okay. And of course, with offsetting, if I choose to offset any polyline, if I join this rectangle again, if I choose any polyline, it will offset all sides of that polyline equally. So if I type in one unit offset into the rectangle, all the distances of all these sides should be 1 unit. So the top here is 1 unit away. The side is 1 unit. The bottom's 1 unit. So on and so forth. Okay. This works with circles. Go back to my 0 layer here. If I offset this circle, then of course, radially around that circle is the same distance between the two circles. Okay. So this distance across anywhere between these two circles is going to be 1 unit. Okay. If you do want to do only one side of a polyline, you are forced to explode it. You do have to explode it and then do your offset just for one side. There's no way to do only one side of a polyline. It has to be exploded. Okay. Any questions about offsetting at all? Okay, if there's no questions, we're going to get into assignment 4 just a little bit here. Let me close this here so it's not in the way. And I'll close this one too. Okay, so back to the week 7 folder. For assignment 4, we have a bunch of files in here. All 5 of these are related to assignment 4 itself. We're going to go through them one by one, just so you're aware what kind of information is in there and where you're going to have to pull that out. So starting out from the top here, assignment 4 deliverables. This is going to look a lot like your other assignment PDFs, asking for what files should be submitted to your Brightspace folder. So with assignment 4 deliverables, in here, it tells you what your task is, complete assignment 4, Arena AutoCAD lighting layout, and to print the drawing to a PDF using the A3 layout, and to not print dimensions or your layout grid. Okay, so we're going to do a layout grid that's very similar to when we did assignment 3. You did those offset grid lines for your electrical symbols and for your text. We're going to do the same thing, except we're not barbarians anymore. We have technology. We know about layers. So we're not going to delete those lines. They might be helpful down the line, or if you ever pull this drawing back up and you need to know what those kind of dimensions were for where to put some of our lighting, we'll be able to recall that just by toggling on or off that layer. So we don't have to delete it and get rid of it permanently. We can just turn off that layer and we don't have to see it when we're done with using it. Okay, so we're keeping the layout grid, but we're just kind of turning it off when we don't need it anymore. There's a list of resources here. This is just kind of referencing to the other PDF files, layout specification and layout details. There isn't really a recorded Zoom video. This is the class that's being recorded for the instructions. And finally, the actual deliverables themselves. 2 files, just like our last couple assignments, to be put in the assignment 4 submit folder, both your drawing file with the correct file name and the PDF that you're going to plot of your drawing as well. Okay, so same naming convention as per usual. And then due date, again, end of semester. There's no kind of hard due date until the end here. Okay, so that's just kind of a brief overview of, yeah, you got to complete assignment 4, how to do the PDF plot, what resources to look at, and what should be in the actual assignment folder. The next file here, Arena AutoCAD Lighting Layout Specification. This is more so kind of like the instructions to the assignment itself. So if I pull that one up, Arena AutoCAD Lighting Layout Specification, it looks like this. It starts off with a cover page and an image. So assignment 4, our job is to put lighting and conduit onto a drawing of a hockey rink or a hockey arena. In true Canadian nature, we're going to put lighting into a hockey rink. So there's a bit of an image of the hockey arena itself. The second page here has our 4 main tasks for this assignment. We're going to make a luminaire layout grid. So a layout grid for where specifically lights are going to be spaced out around the arena and some of the change rooms, the mechanical room as well. We're going to actually put the lighting symbols onto the drawing. So we're going to have a grid that shows us how evenly spaced these lights should be. Then we're going to put the actual lighting symbols into the drawing. Our third task is the luminaire schedule. This is kind of like a little information block that will tell the reader what kind of lights specifically these are. The symbol will tell us kind of generally what that light is supposed to be, but the luminaire schedule itself might be the actual kind of model, the wattage of those lights, maybe the manufacturer, some kind of extra details so people know exactly what type of light they're buying off the shelf or ordering from a provider in order to install into this drawing or into this design. From there, we're also going to do the conduit layout. So it's not enough just to kind of put the lights and evenly space them. We also have to design how those lights are going to be connected by conduit. So there's a little image of conduit here as well. We'll talk about kind of some of the rules with drawing conduit and another image of what that looks like with the actual lights. And then you can see the conduit kind of running across the ceiling here, connecting each of those lights. So we're just doing the lighting for the hockey arena. We're not kind of going into a lot of the mechanical equipment and wiring all of that up. We're just concerned with the actual lights themselves. Okay. So before we get carried away with the task list, I'm going to jump back to the week 7 folder. And our third file here is the arena floor plan drawing file. So this is going to be the basis of your assignment. So you'll download this and you'll open it up and it'll look like this on AutoCAD. Okay. So we have the structural drawing of the actual hockey arena itself. And our job now is to design the lighting for this hockey arena. So this is our basis of our drawing. It has a couple layouts. recall back to the deliverables PDF for which layout you're supposed to print to. And this is our basis. We're going to use this to draw our luminaire grid, our lighting grid layout, and our actual lighting and conduits is all going to be onto this drawing. Okay. So first task here in the Arena AutoCAD lighting layout is the luminaire layout grid itself. So we're going to draw a grid to kind of know how these lights should be evenly spaced into that hockey rink, as well as in some of the dressing rooms and the mechanical room. So here it says luminaire layout grid. We're doing the ice surface area, the mechanical room, and 4 of the dressing rooms. Dressing room 4 and 2, and 3 and 1. And they're kind of split up like that for a reason. We'll get into that in a bit more detail in just a second here. Okay. So our task is to draw a luminaire layout grid on the luminaire layout grid layer. I know it's a lot of L's and lays and luminaires. So we're going to draw out the grid first for the actual spacing. The next question is, how should these lights be spaced? We don't really know that off the back of my hand, right? So what we're going to do is we're going to use offset spacing dimensions from the Luxaflux zonal layout prints. So going back again, week 7 folder, we have a PDF here called Luxaflux zonal Arena luminaire wall offset distances. And this PDF looks something like this. And this is a spec sheet for the actual lights themselves. So we have it broken down by each of those rooms, the ice surface area, the mechanical room, and the 4 dressing rooms. So this contains all the information about the lights themselves. Our kind of more main concern is how these lights should be spaced, because we got to draw them onto the drawing. So scrolling down here, we have a bunch of info about the lights themselves, some info about the room. How big is the room? 12 meters by 6.6 meters. Maybe a height of how high that ceiling is in that room. Suspension length. The lights hang down some distance. What is that distance specifically? This is all not horribly relevant to us. What we're mostly concerned with is the layout itself. So in each one of these pages, you have a bit of a diagram. Well, you have 2 diagrams of how those lights should be spaced. These are all linear luminaires, kind of like the bar lights that you see in a lot of public buildings or stores and stuff like that. So we need to space these out evenly within the room, so the light kind of covers the entire room. It's not concentrated anywhere or anything like that. This is already pre-specified to us, though, so we don't have to do the math of how the lights kind of emit light or anything like that. It's already predetermined for us. Okay. So in the case of the mechanical room, our first job here, we want these lights offset 1.7 meters from the wall horizontally and 1.72 meters vertically from the wall. So to kind of break this down in the layout space here, we have 3 dots going up here for how much space. This is a bit kind of counterintuitive. This is more of a horizontal distance. This is how each column should be placed. Column of lights. So if you have a column, these 2 here, then the next column, these 2 here, then the next column, how much space should be between each column. So not vertical spacing between lights, it's how much space between each column. Okay. Then we have the 3 horizontal line or dots here. That is the row spacing. So not horizontal distance, it is row spacing. Okay. So how much distance between these 5 horizontal lights here in this first row, and then the next 5 lights in the next row. Okay. So this isn't horizontal spacing, it's spacing between rows of lights. So looking at this here, we have 5 lights set into a row here, or 5 columns of lights. So again, column section, value of layout is 5. So we have 5 columns. And then the row section is 2. So we have 2 rows of lights. Okay. We then have the next section, spacing. This is how much space should be between each column or row. In the case of the columns, there should be a distance of 2.17 meters. Again, this is all in meters here. 2.17, if I zoom in on this diagram here, you can see, since this is distance between columns, therefore the distance between this first column, these 2 lights, should be 2.17 meters between these 2 and the next column. Okay, and that's shown by the diagram here. The second column and the third column, there's a little dimension here that says 2.17. So 2.17 meters between columns. Same with the rows. The distance between rows here, 3 dots horizontal means row. 3.17 meters is distance between each row. And you can see on the diagram the distance between these 5 on the first row and these 5 on the second row. The distance on the dimension there is 3.17 meters. Okay.
If I could pose a question here, I'm looking at the mechanical room on the layout details, and it has a higher level of precision. Which measurement would you like us to use? The one on the spec sheet or the one that's on the arena layout?
Preferably the spec sheet. The details one is just kind of a example drawing showing you how it should look across a few of the steps. The Luxaflux one is more specific to the actual dimensions that are used. Okay, so where applicable, use the Luxaflux specs.
So we're going to end up with some weird numbers on our kind of last space, is that right?
Yes. The basis drawing isn't perfect. Whoever designed it kind of wasn't horribly precise, so there's a bit of weird discrepancy in it, but generally you should be following the Luxaflux. Yeah.
Okay, thank you.
Yeah. Okay. So following along here, that is the spacing of those lights. We then have the offset. The offset is the distance from the wall of the room to the lights. So for my offset for each column, the distance is 1.7 meters. So the distance between the wall and the first column of lights is 1.7 meters. Okay. Then same with the rows. The distance between the wall and the first row is 1.72 meters, which is shown here. Okay, so we have spacings and we have offsets. So spacing is the space between a first row or column of lights to the second or third or fourth, whatever the distance is between 2 rows or columns of lights. The offset is the distance between the wall and the first or last row or column of lights. Okay, so this is 1.7 meters from the wall to the first light. Same on the other side, it's 1.7 meters from this right wall to the last column of lights. Okay. So that's something to kind of keep in mind. There's also a 3D kind of diagram here as well. This one also shows the total length and width of that room and the height, I suppose, as well. Just to kind of give you some visual confirmation of what you're reading from the layout table here. Okay. So that's for the mechanical room. If I go now to the next page here, we have dressing rooms 4 and 2. Dressing rooms 4 and 2 on the drawing. These are all labeled here. So we did the mechanical room here first. Dressing rooms 4 in the top left here of the dressing rooms. And dressing room 2 are the same size. So they can follow the same specs. Dressing room 1 and 3 are slightly different size, so we have to have a different spec sheet for those two. Okay, so 4 and 2 are going to be the same. If I go back to my spec sheet again, we have the same layout dimensions. Again, they're circled here to kind of refer back to the difference between offset and spacing. Same idea. We now have 6 columns of lights, unlike the mechanical room that had 5 columns. This one has 6 columns, 2 rows. The space between each column is 2.27 meters. The distance between each row is 3.16 meters. Okay, same with the offsets, distance between the wall and the first row, or the wall and the last row. Same with wall and first column, or wall and last column. Okay, so that's for your offset. Same with dressing rooms 3 and 1. 3 and 1, these values are going to change just a little bit. Before it was 1.74, 1.73. It's now 1.76, 1.73. So this room is slightly different dimensions. 15 meters by 6.6. Believe this one is the same. It's just slightly different spacing from the wall for whatever reason. So be kind of aware and cognizant whether you're doing dressing room 3 and 1 or dressing room 4 and 2. So the spacing is slightly different between them. Okay. Same idea, using the layout information to place your offset lines, and then you'll go in with your luminaire symbols and actually place them in. Okay. And then finally, we have the actual ice surface area itself. This is going to be the biggest one, of course, biggest room. Going through here, 69 meters by 34 meters. And here's our layout again. We have 11 columns and 5 rows. The spacing for each column should be 6.26 meters. The spacing for each row should be 6.65 meters. And then same idea, the amount of offset distance from the wall to the first column or wall to the last column, and the top or first row and the first row here, and the last row and the bottom wall here for my offset distances. Okay. There's a note here as well at the bottom. Your drawing is in millimeters. So you're going to have to do a little bit of unit conversion, not horribly complicated, switching this from meters to millimeters. So if I go back to my drawing file here, if I go and quick measure anything, let me switch my precision back down. If I go in here and measure anything, you can see that this is, if I go to the mechanical room, for example, 6.6 by 12 meters. Okay. Just like it was in the spec sheet here, 6 by 6 or 6.6 by 12 meters for the mechanical room. If I go and actually measure it out, it's 6.6 by 12 meters and some change. Okay. So when you're doing these offsets, these rooms are kind of exact down to the exact specific centimeter or millimeter. I'm not going to be horribly strict on that. As long as your offsets are placed reasonably correctly, I don't have much to really complain about, because your Luxaflux only goes to so much precision, right? So you can use the Luxaflux. There was a comment just earlier. Do you use the Luxaflux or the details PDF? We'll talk about the details PDF as well. it's kind of a toss-up. It's not a big deal if you use one or the other. I'm not really looking for the exactness of that, just because the level of detail on the spec sheet isn't as precise as we'd kind of like it to be. So it's not a huge deal that there's an extra 17 millimeters of height to this room, or an extra 78 millimeters to the width. I'm not going to be highly critical about that. Okay. So using this information, you're going to set your offset grid. So you're going to go back into here, or back into your drawing, and you're going to use those dimensions to draw a grid in each of these rooms. So the mechanical room, dressing rooms, and the ice surface itself. We're not doing anything in the electrical room or Zamboni room or kitchen or main office. We're not touching those at all. Okay. So what you should end up with after you do that is something that looks like this. Okay. So they've gone through and they've set all their offsets based on those specs. Go in and kind of measure them. Again, you can see like on this one, there's a bit of a hanging decimal there. That's not a huge issue to me. Okay. So go through, put in your offsets in here. Same with the dressing rooms, placing offsets. Make sure your offsets are on the right layer. We're using the luminaire layout grid because this is a layout grid for the luminaires. So we're drawing this on that specific layer. Okay. And this is where it comes in handy when we're talking about offsets, where you offset to current layer. You could set this luminaire layout grid as your current layer, switch your offset settings, going into offset, layer, current. And now whenever you draw your offset lines, they'll be sent to the current layer, which is what you set, the luminaire layout grid. Okay, save you a little bit of time. If you set it to source, it's not a big deal. You just have to go back to all those grid lines, select them, and then swap them to the correct layer. Okay, so you'll draw out your layout grid here. Going back to my specifications PDF here. Arena AutoCAD lighting layout specification again. Draw the luminaire layout grid on the luminaire layout grid layer. Use offset spacing dimension from the Luxiflux local prints or layout prints. Determine the exact spacing on the Arena floor plan using the available AutoCAD tools. Again, just using the tools available to you to make that layout grid. Okay. There's a note here for following the detailed PDF examples provided. That is in the AutoCAD lighting layout details PDF. So that's the last one we haven't looked into just yet. We talked about deliverables. That's just how should you plot it? How should you name it? Where does it go? The layout specification, which is the instructions, the actual drawing file, the Luxiflux zonal, which was our spec sheets. Finally, this PDF for details is this one here. So AutoCAD lighting layout details. This is kind of a step-by-step example of what your drawing should look like as you kind of go along. Okay. So after you've gone through your first step of making the layout grids, this is an example of what that should look like. They now have their layout grids in place. It generally kind of looks like this in your drawing. Okay. So they've gone through, measured it out, put their offsets. If I scroll down here, they also have specific dimensions that they used. Not all of the dimensions are listed here, so you have to do a bit of looking around to other rooms, maybe since 4 and 2 are similar. If you choose to use these dimensions, I'm not going to bag you on it or anything like that. If you do want to use these dimensions instead, by all means. But the spacing here, they have the offsets, spacing horizontal. They don't have the spacing vertical here in dressing room 4. So I'm going to have to look around a little bit, I know dressing room 2 has the same dimensions. And what do you know? There is the vertical spacing, okay? The row spacing in this case. So if you do choose to use these dimensions, you can. They're going to be less kind of particular. In some cases, more particular than others. I'm not going to beg you on using this one or the Luxaflux. Generally, use the Luxaflux where kind of applicable. If you do have some cases where there's a bit of inaccuracy, it's not going to be a huge deal, okay? Again, this is testing more for things like layers and for our advanced editing tools that we're going to be talking about. So I'm not highly concerned about things that are kind of not relevant to that, okay? So there's some dimensions here, if you choose to use them. Our next step is then to actually place the luminaire symbols onto the grid. So we develop the grid based on the spacing, the specs. Now we need to actually put the lighting symbols onto that grid. So back to my specifications PDF here. We've gone through, made our luminaire layout grid. It's on the right layer, yada, yada. Here's a little list of maybe some of the tools that might come in handy for doing some of this work. Going down to our second task, task 2, is to make the luminaire layout itself. Again, we're doing the ice surface area, mechanical room, 4 dressing rooms. We are to use the correct luminaire symbol from the symbol legend and the luminaires layer to place the luminaires on the arena floor plan as per the detail examples. So what that means is that I don't believe it says it in here. We'll go to the details. So we need to get the correct lighting symbol from the legend. If I go back to my drawing file here, the basis, we have a symbol legend in the top right. We're using suspended LED luminaires, so this guy here. And we're also using pendant LED luminaires, this guy here. So you don't have to make the symbols yourself. You can pull them from the legend here. You can copy them out and then switch them to whatever layer you need them on, okay? So you don't have to make these symbols from scratch. You can just pull them, copy them from the legend, and then go ahead and place them onto your drawing, okay? So going to the details file here, you can see they've made their grid. They're now placing the luminaires. Similar to assignment 3, these luminaire symbols should be centered properly onto the drawing, okay? So they're not using the center point of the circle in this case. They're using the center point or geometric center of this rectangle, okay? So we want them evenly spaced on the grid itself. Again, these are symbols. They're not representative of the actual size of the lights in particular. So we just want to make sure people are aware that these are centered along where they're supposed to be placed, okay? So we're using the center of the symbol, plopping it down on each of those grid intersections. This is dressing room 4. We'll also do the same with the ice surface. So make sure you grab the correct symbol for the ice surface. It's a different symbol, and you'll grab those and plop them on each intersection in the ice surface, okay? So same idea, using the center of the symbol on the intersections. And once you've done that, we are good with task 2. So task 2, you've got the right symbol. You can grab it from the symbol legend. Make sure the symbols are on the correct layer. We have a bunch of layers in this drawing. Make sure you're using the correct one for where the symbols should be placed on. And then follow along with the detail examples, okay? So that's task 2, actually putting the lights onto the grid. So Moving on from that to task 3, we're now going to complete the luminaire schedule. So the schedule is going to have a bunch of data information for what those lights are specifically supposed to be, what make and model those light bulbs are, or those lighting fixtures are. We're going to be inserting that data on the correct layer again, luminaire schedule text, and we're going to copy that information from the details file. So again, on the details file, if I scroll all the way down here, there is a sample luminaire schedule, and I'm going to be copying this information into the luminaire schedule on my drawing. So in the bottom left here, there's a table. It has the type, description, lamp, MTG, volts, watts, manufacturer, any remarks. We're going to be filling out all this table just as it is here in the details file. Okay, so all this information should be accurate. It's a bit of an attention to detail kind of exercise. All this information should be exact. We don't want to accidentally have someone going out and purchasing a bunch of the incorrect wattage or voltage of lights. That would be a huge disaster. So we want to make sure this information is exact. Okay. In the case of the type section here, we have these little hexagon shapes with numbers in them. You can grab those. There's a sample one given to you. You can grab these and copy them out. If you double click on them, you can also change what the number is inside that hexagon. Okay. So I just double click on that block there, and it's allowing me to change the number in there. I can switch this something like 101, hit apply, hit OK, and now the number in there is 101. Okay. What we're also going to be doing with that type symbol is placing it within the drawing itself. So we've described what lighting fixtures these are supposed to be specifically. Now we need to identify where they are on the drawing. And the way we do that is by going back up here. You can see for dressing room 4 here, they've plopped one of those symbols with the associated value from the table. So dressing room 4 uses the 100 type lights. If I go back to this example here, or back to the details rather, let's go back down here. I then check type 100. Was this failsafe, HVL, linear, vandal, resistant, light, whatever? Remarks, it is being used in the dressing rooms. Okay, so the remarks is going to tell you where that light is as well. So dressing rooms is the type 100. If I go back here, ice surface area is the type 200. So if I go back to their sample drawings here, I can see on the ice surface, they have type 200 on the ice surface here. Every other kind of row here, they've put a little label to let you know that's the type of light being used there. And if I go back up to the dressing room, they've put a little tag beside the dressing room text, letting me know that that's the type of light being used in dressing room 4. Okay. So the exact placement of this tag is also not highly critical. It shouldn't be placed just kind of somewhere random in the room. Personally, I'd align it with the text, kind of centered alongside the text in this case. The amount of distance that you put it left or right here, again, doesn't really matter. There is a factor of kind of a neatness mark, so you should keep it relatively neat and organized, but the exact placement of this tag isn't highly critical, okay? This doesn't represent anything in physical space. No one's going to go out there and engrave the number 100 on the ground. So the exact placement of this 100 marker isn't particularly important, okay? But again, there is a factor of neatness, a factor of organization. It shouldn't be like stuck in the corner or something or overlapping other lines. Be reasonable with it, okay? So I think that covers it for the specification. Yeah, for the schedule, make sure all the information is accurate, and then make sure your type tags are actually on the drawing as well. Okay. So that covers our luminaire schedule. There's a bit of information here about what that text is supposed to be, the size of the text in the schedule itself. So the text style, we're just using standard. If I go back into here, we're by default on the standard text. You shouldn't really have to change it. If you accidentally do change it, you just go to your annotate tab. We talked about this a bit briefly when we talked about text. Just make sure it's on standard. Okay. It's on it by default. You shouldn't have to change anything. When it comes to the actual text height, the title itself is 5 millimeters, the header is 4, and the data, the actual text you're going to input into the luminaire schedule is height 2.5. Okay. So when you go through here and go to annotate, just make sure you're on 2.5 text size before you use multi-line, and then go ahead and intersection and put in your text. Okay. So this can be whatever it's supposed to be. You might want to justify it and place it in there. Okay. And making sure it is 2.5 text size or text height. Okay. Make sure again that that text is on the right layer, luminaire schedule text. And moving on to the final task here. So I've gone through, I've taken my drawing, we put our schedule in, we wrote all our text in here, we've made our grid lines. I've also put on the actual light symbols themselves. We should be at this point here. Now our job is to design the conduit, so the connections between the lighting. In this case, what we can do from here is that we have this layout grid. We don't really need the layout grid anymore. We've already placed the lighting down, and the only purpose of the grid was for the spacing of the lighting. You can now go to your layout grid and just turn it off. Okay. You don't have to go and delete the entire luminaire grid. In fact, you shouldn't delete the entire luminaire grid because I have to check it for grading. So just simply turn that layer off. You're left with just the luminaire symbols that you've drawn. And now we're going to draw a conduit. Okay. So we got to draw the connections between each of these lighting symbols. And going back to my specifications PDF, we have our task here, provide conduit layout and connections to luminaires correctly as required. Conduit runs, these are your rules. Conduit runs should be neat in appearance. They shouldn't be kind of overlapping other lines or not correctly connecting to lights, things like that. They should be straight, parallel to building structural lines. The general rule of thumb for conduit is that it either runs parallel, perpendicular, or 45 degrees to building structural lines. So what that means is your conduit, if I look at any walls in this building, the conduit should be, actually, let me use a different layer. The conduit should be parallel to that wall, either parallel to the wall, it can be perpendicular to that wall, or it can be at any 45-degree angle. So 45 could be at this 45, could be at this 45, could be at this 45. These are the only acceptable angles for conduit. So parallel to the building lines, perpendicular to the building lines, or at any 45-degree angle. Reason for that being, no one's going to bend your conduit. No electrician out in the field is going to bend your conduit to 17.6 degrees. They're just not going to do that. Okay. It's just not practical for anyone to be building and bending conduit to such weird, precise angles. So they're generally standardized to 90 degrees or 45 degrees. Okay. So our conduit lines in our drawing should reflect that. They're also going to be always 90 degrees or 45 degrees to the actual walls of the building. Okay. Finally on here, last important part is that the conduit itself should connect to the luminaires correctly. Going back to my details file here, there's some examples of how your conduit should connect to your luminaires. So in the case of the linear LED luminaires here, you can see their conduit, this line that's kind of running horizontally here. It's running perpendicular. If there's a vertical wall here, runs perpendicular, 45 degrees up to the circle of the luminaire, that bottom south quadrant, and then 45 degrees out, and then back to 90 degrees, and then off to the next luminaire here. Okay. Now, the next question is, well, this is 45 degrees. What should this distance be? How far should the conduit be from the lights? That is also not an exact science. Okay. The amount of distance this conduit should be from the actual luminaire, again, not going to be horribly strict. The more strict end of things is that it should be 45 degrees. Okay. Now, that being said, again, be reasonable with it. It shouldn't be a huge distance away from the from the luminaires. It should also not be extremely close to almost looking like it overlaps with the luminaires. Keep it reasonable. The more strict part is that these are 45-degree angles. Okay. So if I go back in here and I'll turn on their conduit layer, you can see that they've connected them all. The exact distance here, you can see they use something completely arbitrary between the distance between the conduit and the luminaire itself. Again, not a huge deal. Okay. But again, keep it reasonable. And they connect it to the quadrant of the circle, not to the edge of the rectangle. Okay. This details file also kind of shows that. Same with the medallion lights. When you place it on your grid's going to look like it passes through these medallions. When you actually go to make the conduit, again, the conduit itself doesn't run through the symbol. There shouldn't be any conduit within the symbol for the luminaire itself. Okay. Again, just for organization, showing that it's a connection to the luminaire, but it's not part of the symbol. Okay. So if someone goes and prints this out in black and white and your line goes through the symbol, now it's a bit ambiguous about what exactly that symbol is supposed to be. Okay. So you have samples here for both the linear and the medallion lights for how those conduit connections should look. And at the end, you should have something that looks like this. Okay. Again, in the details as well, they have a diagram here or an example of how your conduit should look. It shouldn't be a full ring connection between all the lights. It should just connect from the first to the last, no final connection between the first and last though. Okay. So just like this, just like the example, you're pretty much using, again, this is an AutoCAD course. It's not strictly some sort of design course. So we are just following along with the examples, testing more so for the AutoCAD skills. that we've covered recently. Okay. So that's pretty much it. After you've done your conduit, make sure you adhere to your rules here. Your conduit should be on the conduit layer, of course, and then it should be connected to the luminaires as per the PDF detail examples. Okay. And that is your 4 tasks that you need to do for this assignment. Any questions at all about what to kind of expect or how to do any of this stuff or anything like that?
So the unit, we have to convert all the values to millimeters?
Yes. So
Okay.
if you're using the Luxiflux zonal values, Luxiflux zonal is all in meters. So 6.65 meters, 3.53 meters. The drawing itself is in millimeters. AutoCAD has no way to kind of just translate that in. You're going to have to do your own mental math, multiply it by 1,000 to convert from meters to millimeters. Okay.
Okay. Okay.
Yeah. Yeah. Good question though. Any other questions at all? Of course, this week is pretty low on the amount of lecturing. So when it comes Thursday, you're going to have a lot of time to work through it. You can always email me in between if you're having any troubles or anything like that. I can help walk you through it as well. Okay. So with that, I don't have anything else left to kind of talk about. The last 20 minutes or so, if you choose, you want to start with assignment 4. I know there's a big group of people that are kind of keen on starting early. By all means, you can spend the next 20 minutes working on that. If you don't want to quite get started on yet and just make sure you're up to date with your other skills, you can go through the practice problems listed on the task list. That's in chapter 11, practice 11A, 11B, and 11G. You can go through those just to kind of make sure you're up to date with trim, extend, and offset. For Thursday, the plan is I'll go through those 3 practice problems just as a class to kind of demonstrate. And then again, the rest of the class time is to work on assignment 4. Okay. So we'll stick around for the next 20 minutes. If you have any questions, just feel free to ask. If you want to leave early, I don't have problems with that either. But the rest of the time is just to either work on practice problems from chapter 11 or on assignment 4. Okay.
Brent, to find geometric centers of things that aren't exactly a shape, but made out of multiple lines that kind of intersect, is there a way
Yep.
to do that, or?
So you might have to be a little bit more creative with your object snaps. With the, I believe you're probably talking about with the linear luminaire symbol, the rectangle. Uh,
Yeah,
I don't believe it
that and this
has,
other thing.
yeah, I don't believe it has a perfect geometric center to it. So you might have to be a little bit creative with how you go about finding the center of that. Maybe using a different object snap or a combination of a couple object snaps to find the center point as a little bit of a hint.
Yep, yep. So I got through that, but I'm just being very meticulous with the Luminaire schedule as well, in having the text centered in the space, and every
Ah,
grid seems to kind of not have a geometric center, and I'm not too sure if it's because I'm doing something wrong or if it's just a limitation from AutoCAD.
you're saying the grid doesn't have a geometric center?
The Luminaire schedules look kind of like the center of each
Oh, I
box,
see.
or at
Yeah.
least it's not allowing me to snap.
Uh, what I'd use instead in the Luminaire schedule is just using multi-line text and then drawing the box based on the intersection points.
Okay.
Does that make sense?
Yeah.
Yeah. So I just use multi-line in this case. Generally speaking, I probably use multi-line like 90% of the time. With intersection, you can easily grab both corners and then justify it to the middle center.
Yeah, that's
Yeah.
way better. Thank you.
Yeah. Yep. Single line text, the names are a little like misleading, I'd say. Multi-line text is more of like the advanced tool because it has just so many more options. And single line is just kind of more the quick and easy way to draw text if you just want to kind of throw it wherever.
Yeah, I find it interesting that the hotkey just instantly takes you to multi-line.
Yeah.
Okay.
Any final questions before we kind of wrap up in a couple minutes here?
Yeah. Can you show one more time, please, how you are aligning center left when you are drawing your box?
Sure.
Please.
Okay. So let me go to the fresh one here. So I'm just grabbing multi-line text. Make sure I have intersection snap on. And then from the corners of the box for my multi-line. And then make sure I change my justification. Whatever alignment fits the bill, middle center or middle left. I believe it uses middle center. Go double check. Yeah, this looks centered. There's even space on both sides of the text. So I'll use multi-line text, 2 corners, switch this justification to middle center, and then put in my text, and then it's centered in the box. Yeah.
Thank you. I didn't realize there was the drop-down menu there.
Oh, yeah. Any other questions at all before we wrap up? Of course, you can always send me an email or wait until Thursday's class if you have any questions. Okay, if there's no questions, I'm going to wrap up for tonight. I'm just going to shut in the meeting. Again, if you have any questions, just shoot me an email. Provide as much detail as possible, and I'll get back to you as soon as possible. Okay.
Thank you, Ben.
So, yeah, no problem. See you guys Thursday.